So moving on to lesson 4 in our numeracy unit, we're going to talk about properties of addition and multiplication. But before we do that, we need to talk about what it means for expressions to be equivalent. Now, first of all, I want you to understand that an expression is just a mathematical statement. So something like 5 plus 2 would be an example of an expression. We can bring variables into the picture and say something like 5x is an expression. But for an expression to be equivalent, it means that it's equal. It gives us the same result. So what does it mean for expressions to be equivalent? It means the results are the same. Well, the results are equal, however you want to say it, but that's what's really important. And you can see in the word equivalent, almost the word equal showing up in it. Okay, so it's really important for us to understand again that these properties we're going to talk about apply only to addition and multiplication. So I'm going to walk you through each of the properties. I'm going to highlight the key characteristics of each property, and then I'm going to quickly give you an example. So the first of the properties is the commutative property. Now think about the word commute. When some of you have parents or family members that take the commuter rail and they commute into Boston, and when they come home, they hop on the same train and they commute back to town. So it's the same equal distance trip, but in reverse order. So that's what the key is to the commutative property. What we can say is changing the order. Changing the order. Let's try to erase this because I hit a button that's glitching things out. Changing the order does not change the value. So an example in addition, take two numbers and add them, something like 5 plus 2. We already know that's a value of 7. If we change the order and instead think of it as 2 plus 5, that does not change the value. The left side is an expression that's equal to 7. The right side is an expression equal to 7. So changing the value, or I'm sorry, changing the order does not change the value of the outcome. So we can also see this in multiplication. Let's say we do something like 3 times 6. We should know that's 18. And if we change the order, 6 times 3 is also 18. So changing the order does not change the value. So essentially, order does not matter. Okay? So moving on to the next property, the associative property, that is a little bit different. With the associative property, think about associating, okay? And when I think about associating, I think about grouping. And when I think about grouping mathematically, I think about parentheses, okay? So in this case, if we change the grouping or changing the grouping, does not change the value. So this is not about changing order. You're going to see in the two examples, the order stays the same. It's just how we group the numbers that is going to change how we go about adding the numbers or multiplying the numbers in a particular order. So let's do something like 2 plus 4 grouped together plus, let's see, 7. Well, if we think about order of operations, we know that 2 plus 4 is 6, plus 7 is 13. I actually want to write this a little bit smaller because I'm going to need the space to show the other side. Now on the other side, I'm actually going to keep the numbers in the same order. 2 plus 4, but this time the 4 plus the 7 are going to be in parentheses. Now again, if you think about order of operations, I would do 4 plus 7. So actually, let's just do that. So 4 plus 2, 2 plus 4 is 6. 6 plus 7 is 13. Over here, from an order of operations standpoint, in parentheses, 4 plus 7 is 11, plus 2 is also 13. So you notice we get the same result. Okay, so this is going to actually hold true when it comes to the associative property of multiplication. So if I take three numbers, let's see, 2 times 3 times 4, and I'm going to, if you notice, I'm going to write those numbers in the same order, 2 times 3 times 4. The only thing I'm going to do is change the grouping of how the numbers are associated. So again, think about order of operations. 2 times 3, that's 6 times 4. 6 times 4 is 24. Over here in the parentheses, we would do 3 times 4 is 12 times the 2, and that still gives us 24. So notice we're maintaining this equivalency, equal outcomes, okay? So again, before we move on to the next two properties, in the case of the associative property, it's the grouping that can change, but the order does not. In the case of the commutative property, it's the order that changes. You notice there's no grouping, there's no parentheses here. So that's going to be, when we talk about these further, what will help us see some of the telltale signs of these properties. Okay? So there's two more properties for us to think about. The identity property is actually going to look a little bit different in the case of addition versus multiplication, but the characteristic is going to be the same. So let's take a look at that. So moving on with the identity property, let's think about what it means to maintain an identity. Identity is kind of keeping your name, right? Your identity is your name. So think about the identity of a number as being its value. So how do we keep a number's identity by way of addition versus multiplication? As I said, the earlier two properties looked very similar with addition and multiplication. So here we're going to begin to see these properties look a little bit different. So the key characteristic with identity is that the original value does not change. The original value does not change. Okay? So that's really key here. The original value does not change. So, for example, if I start with the number 8, and because of addition I want to add something to it, what will I add to it so that I still get the same value of 8? That seems pretty obvious. 8 plus 0. Okay, so that's key right there. But on the other hand, if I start with a number, and oh, by the way, I want you to understand that these numbers can be positive or negative, fractions or decimals. So let's take a number like negative 3/4, a negative number, that's a fraction. What would I have to multiply it by so it keeps its identity, so it keeps its value? And we should know that that would be that we have to multiply it by 1. So how do we keep the value? We're going to either add 0, we're either going to add 0, or we're going to multiply by 1. That's how we keep a number's identity. Okay, so now we're venturing into our properties looking a little bit different. As I said, the commutative property, you notice, other than the order changing, the only thing that's different in addition and multiplication is the type of operation. Likewise for the associative property. Notice the numbers didn't change, the groupings changed, but the only other thing that changed otherwise in the examples is the operation, multiplying versus addition. But when we get to the identity property, and also for this last property, the inverse property, we have to be a little more mindful of what the clues are, okay? So remember, with the inverse property, if we add 0 to a number, we keep its value, we keep its identity. Likewise, when we multiply by 1, we keep a number's identity, we keep a number's value. So with the inverse property, the key characteristic is going to be a little bit different. So I'm actually going to break this down. So for addition, the result is 0. And for a multiplication, the result is 1. So if you think about inverse, and this is easy to think about with addition, inverse we can think of as opposites, okay? So if I'm looking to find two numbers that when I add them equals 0, they naturally have to be opposites. So something like, let's say, 2 plus -2. Well, that's like saying 2 minus 2, and that equals 0. Okay? But when it comes to multiplication, the result is going to be 1. And that's going to be a little trickier. Okay? So here we see these numbers are opposites. Whereas here, we're going to see that these numbers, to multiply to get them equal to 1, if I take the number 6, I'm going to have to multiply it by something in such a way that that 6 cancels out. And this is bringing us into some discussion of fractions that we haven't really gone back to talking, or we haven't revisited yet this year. But if I multiply it by 1/6, check this out. I can take 6, I can write it over 1, and I can do the magic of cross canceling, and now we get the equivalent of 1 times 1 is equal to 1. Here, these numbers are what we call reciprocals. Okay, so when it comes to getting a result of 0, when we add, we need numbers to be opposites. They're inverses of each other. And from a multiplication standpoint, to get a result of 1, those numbers need to be reciprocals of each other. Okay, and that's another way of thinking about inverse mathematically. So those are your 4 properties that you're responsible for. The commutative property, order does not matter. The associative property, grouping does not matter. The identity property, the value does not change. And by the way, these are equivalent. 8 plus 0 gives us 8 is equivalent to the 8 as an expression on its own on the other side. So we're maintaining equivalency. In the inverse property, in which we get a result of 0, because again, maintaining equivalency, adding opposites, 2 plus -2 is equal as an expression to the expression of 0 on the other side, or because of multiplying reciprocals, 6 times 1/6 is equivalent to the expression of 1 on the other side. So that's a lot to throw at you. Replay this video as often as you need, and do the assignment that goes along with this that was posted in today's Google slide. And we'll explore these concepts more tomorrow.